Welcome back, everybody, to the afternoon sessions for track 2. My name's Josh. I'm here with my co-host Chris.
Hi, folks.
And as always, before we get started, if you're not already, please make sure that you hop onto Slack to ask any questions and to network and chat with the speakers today. That's slack.cncf.io, and we're in the KCD-UK channel. So yeah, and as always, we have workshops later this week, workshops.kcduk.io. And with that, I will hand over to our next speaker, Arsh Sharma. Arsh joins us from VMware, and he's going to be talking to us today about a guide to evaluating dependency updates to Kubernetes. And on that, I will hand over to Arsh.
Hey everyone, I hope you're all having a good conference. I'm super excited to be here. Can someone please confirm if the audio and all right, let's get started. So hello everyone and welcome to Kubernetes Community Days UK. I'm Arsh, I work at VMware. I'm also on the current Kubernetes release team, and this session is going to be about how we evaluate dependency updates in the upstream Kubernetes project. So let's get started. Before we begin, I want to give a brief overview of what I'll be covering in the talk. I want to keep this session very beginner friendly. So without assuming any prior knowledge, we'll start by a brief intro to what dependencies even are, how Go handles them, and why should you even care about your project dependencies in the first place. Then I'll introduce you to depstat, which is the command line tool we use in the upstream project to analyze dependencies. I'll first show you all the subcommands it offers, and then we'll look at how exactly we use it for the Kubernetes repository. In the end, I'll touch on how I got the opportunity to work on this project, and I'll also go over some of the mentorship opportunities available if you too are looking to contribute to the upstream Kubernetes project. So first things first, what are dependencies? Well, dependencies, put simply, are external packages which your code uses. These external packages are distributed as modules. As per the definition of a module in Go, it is nothing but a directory containing a collection of nested and related Go packages with a go.mod file at its root. If you aren't familiar with what a go.mod file is, don't worry, I'll be covering that in the next few slides. All of this jargon sounds too complicated. Just look at this super simple example. Here you will see that to make HTTP requests in our code, we are using this very common module called Julian Schmidt HTTP router, which then ends up being a dependency of our project. Simple enough. If you look closely though, you'll see that there are other packages and modules that we are importing to, for example, FMT, log, net, HTTP, but they are internal to Go, so we do not consider them as dependencies of our project. So by default, if you create a main.go file and start writing code in it, you won't get the support of Go's dependency management tools. You will need to put your code in its own module in order to track and manage the dependencies you add. You can do this by running the go mod init command and then specifying the name of your module. A fun fact here is that now, since your code is present in its own module, if you put it on GitHub or something, others can import it and then they would have a dependency on your module in their project. Once you put your code in its own module, you'll see that a go.mod file appears in your project directory. A go.mod file simply describes the module's properties, including its dependencies on other modules and on versions of Go. If you see to the left, you'll see that this is an example of a very simple go.mod file. When you add dependencies, Go tools also create a go.sum file that contains the checksums of the modules you depend on. Go uses this to verify the integrity of the downloaded module files. Please note here that the go.sum file is auto-generated based on your go.mod file, and you should never need to edit it manually. To keep your managed dependency set tidy, you can use the go mod tidy command. Using the set of packages you have imported in your code, for example, Julian Schmidt HTTP router here in this image. The go.mod tidy command edits your go.mod file to add the modules that are necessary but missing. It will also remove the unused modules that do not provide any relevant packages. So say in this example of go.mod file, if you stopped using example.com, this module, then when you run go.mod tidy, it will remove that line. Lastly, it will also regenerate the go.sum file based on the updated go.mod file. So now that you know what dependencies are and how Go handles them, let's talk a bit about why should you even care about managing and keeping track of your dependencies. Well, the thing is that sooner or later, you would have to update the dependencies of your project. This might be because you want the changes in the latest release of that dependency. But let's say that if you're satisfied with the current set of features, you might still have to update the dependencies because of a security vulnerability found in the older release of a dependency, which got fixed in a newer one. And updating dependencies brings with it a whole set of new headaches. You'll have to make sure that it doesn't break the current code and that it is compatible with the existing versions of other dependencies in your project. So I think when it comes to dependencies, it's safe to say the lesser the better. Now, this does not mean that you should try implementing the functionality of each package on your own. The reason I say that lesser dependencies are better, it's because it'll mean that you'll have to keep track of fewer releases of dependencies for your project, and you'll have a much easier time updating those dependencies. Now, all of this might seem very trivial for a small project, and to be very honest, you could get away with not caring about dependencies at all. But when a project grows to the size of Kubernetes, all of this becomes very important. Updating dependencies could often mean breaking stuff. Skipping a crucial update could mean exposing a lot of users to a security risk. So long story short, the simpler the dependency chains are, the better. And being particular about your project's dependencies right from the start and tracking them is extremely helpful in the long run when your project grows to a huge size. It was to solve these very problems in upstream Kubernetes that we created depstat. So before we see what depstat is, let me go over what we wanted out of this tool. I mean, we knew that we needed something to analyze dependencies, but what should this thing do? The biggest problem we wanted to solve was that with the Kubernetes repository receiving so many pull requests, it was getting tough to notice which of these were changing dependencies. Not only that, but more importantly, how were these PRs changing the dependencies? What was the impact of these changes? Were these changes to direct dependencies or transitive dependencies? I'll get into those later. We also wanted there to be a way using which PR authors can themselves see the impact of dependency changes they are making without them having to rely on one of the maintainers. And it was to solve all these set of problems that we came up with depstat. So let's see what it is. Depstat is a command line tool for analyzing dependencies of Go modules enabled projects. You can install it by running go install github.com/kubernetes/depstat and get the latest version. Or you can also download the latest binary from the GitHub repository. It provides us with 4 subcommands, each of which I'll be now going over in the following slides. The first and the most important thing from the point of view of upstream Kubernetes, which depstat provides us with, is the stats subcommand. Running depstat stats in your project directory would give an output which would look something like this. It would show you the number of direct dependencies, transitive dependencies, total dependencies, and the max depth of dependencies. Let us now go over what each of these means. Direct dependencies, as the name suggests, are dependencies which are used by us in our project directly. Well, what does directly using them mean? If we go back to the previous code, we'll see here that we import Julian Schmidt HTTP router, and then in the first line under the main function, we use it. Now, if this module internally uses something else to do what it does, we do not care about that, even though that is technically essential for our code to function properly. So in this case, Julian Schmidt HTTP router would be a direct dependency of our project, and whatever external module, let's say if any Julian Schmidt HTTP router was using internally to do what it does, that would end up being a transitive dependency of our project. To sum it up, transitive dependencies are nothing but dependencies which are further needed by direct dependencies of our module. Another way to put it would be that they are the direct dependencies of the direct dependencies of our module. The next thing in the output is the total number of dependencies of our project, which is pretty self-explanatory, apart from one slight caveat. Even though here in this example, you see that the sum of direct dependencies and transitive dependencies is equal to the total number of dependencies, it does not necessarily have to be so. Now, why is that? Simply because a dependency can be both a direct as well as a transitive dependency. This is best explained with the following example. Let's say our module depends on this module called woof, which internally uses this other module called meow. But our module also directly uses meow. So like in the previous code, we were importing Julian Schmidt HTTP router. We are importing meow and woof. The only thing is that woof also internally uses meow. So in this case, meow would be both a direct as well as a transitive dependency of our project. So if you see in this example, the number of direct dependencies is 2, woof and meow. The number of transitive dependencies is 1, just meow. But the total number of dependencies is not 2 plus 1. Rather, it is just 2, which are woof and meow. So this is the reason that it is not always necessary for the total dependencies to be equal to the sum of direct and transitive dependencies. The final thing in the output is the max depth of dependencies, which is nothing but the length of the longest dependency chain. Going back to the previous slide, we see that there are 2 dependency chains here. One is from our module to woof to meow, which has a length of 3, and the other is from our module to meow, which has a length of 2. So in this case, the max depth of dependencies would have been 3. You can also run the stats subcommand with the verbose mode on to see the actual chain whose length is shown, whose length is calculated by the max depth of dependencies. So the second subcommand depstat provides us is the graph subcommand. This generates a graph.dot file, which can be used by graphviz.command to visualize the dependencies of your project. Graphviz, for those of you who are not familiar, is another command line tool which provides a way of representing structural information as diagrams of graphs. So if you look here, you can run the depstat graph command and it will inform you that it has created a graph.dot file. It is this file that GraphViz will use to generate the actual graph. Running the GraphViz command to generate the graph, you would see that a dag.svg file appears in your project directory. If you open this file, you should see a graph which would look something like this. Highlighted in yellow will be your main project module, and from that you can visualize the direct dependencies coming out, and from those you will see the transitive dependencies originating further. This is the graph produced by a simple Go modules project I had created for this talk, but I also want to show you the beauty which gets generated when we create a graph out of all dependencies of the Kubernetes project. Beautiful, isn't it? This should give you an idea of how complex dependency chains can get in a project as large as Kubernetes and why we need ways to analyze these dependencies. The graph subcommand also comes with a useful flag, which lets you specify a particular dependency whose chains you want to be highlighted. So let's say you only want to see the chains which have github.com/kr/text in them, then you can run the command shown and you would see an output similar to what you see right now. The third subcommand that depstat provides us with is the cycles subcommand. What this does is show all the cycles present in the dependencies of a project. An example of cycles in project dependencies is if A depends on B, which depends on C, which again depends on A. So here for this simple project I've been using till now, you'll see that the cycles in the dependencies are due to X net depending on X crypto and vice versa. For Kubernetes, there are many more cycles, no surprise, which are also much more complicated. And this isn't even the complete output of the command. This is just what I could fit in on this slide. The final subcommand depstat provides us with is a very simple one, which is depstat list. This simply prints a sorted list of all project dependencies. So now that you know what depstat does, let me go over how we use it in the upstream Kubernetes project. Depstat runs as part of two prow jobs for the Kubernetes repository. What is prow, you might ask? Prow is a Kubernetes-based CI/CD system. Prow jobs can be triggered by various types of events and report their statuses to many different services. To put it in very simple terms and in the context of this talk, prow is basically responsible for running certain tests on your PRs that are made. It can also run these tests on the master branch of the Kubernetes repository. For depstat, we have two prow jobs. One is a periodic job which runs once every 6 hours on the master branch of Kubernetes/Kubernetes. KK, for those of you who are not familiar, is short for Kubernetes/Kubernetes, which is the Kubernetes GitHub repository. So this periodic job would produce an output which would look something like this once every 6 hours, which is running the depstat stats command and then showing the output. We also have a pre-submit prow job which runs automatically on pull requests which change either the go.mod file, the go.sum file, or any other files in the vendor directory, which is where the stuff related to dependencies is present in the Kubernetes repo. This can also be manually triggered on the pull requests by commenting /test check dependency stats. And this is all thanks to prow. What this job does is run depstat on the code which is present in the pull request and then prints its difference with the output of running depstat on the master branch of the Kubernetes repository. This way we get to know what will change in terms of dependencies for the Kubernetes repo if we merge that particular PR. So if your PR changes dependencies, prow would catch that and run the check dependency stats job, which would give an output similar to the one you see on right. Here for this particular PR, the number of direct dependencies was being changed by 1, which is what depstat captured and reported. Here is another example of a PR where a total of 16 dependencies were removed, which is a huge number and goes a long way in improving the dependency chains of Kubernetes. So now, finally, to conclude, I want to touch a bit upon how I got the opportunity to work on this project as a student and how you too can get started with the help of various mentorship opportunities the Kubernetes community provides. I applied to this program called the Linux Foundation Mentorship. Luckily, I got selected and got the opportunity to be mentored by DIMS, who most people who have been involved in the Kubernetes community would know. Going from almost no prior knowledge of Kubernetes or Go, I learned a lot from him while working on this project. This is why I would highly encourage everyone, regardless of their existing knowledge, to apply to these opportunities if you're looking to get started contributing to open source projects like Kubernetes. My only request would be that please do not self-reject when applying to these mentorships, thinking that you do not know enough. As Tim's perfectly put it, we are all learning all the time. So please do not hesitate asking questions or applying. Lastly, I want to go over a few other programs which you can apply to. One common misconception is with these programs that they are only for university students. That is not at all true. The Linux Foundation Mentorship Program runs thrice a year and is open to everyone. Similarly, for each Kubernetes release, there is a release team, and you can apply to be on the release team where a release role lead would mentor 4 or 5 shadows under them. This is another excellent opportunity to learn the ropes of the Kubernetes project. There is also the Google Summer of Code program, which runs once a year, and this is only for students. Personally, I have been part of all 3 of these, and I can easily say that they have helped me learn and grow a lot. You can read about more such opportunities by visiting the link on this slide. So this was it from my side, and thank you so much for attending. If you have any questions, please feel free to put them on Slack or reach out to me on Twitter or drop a mail. You can find the links to these slides at arsharma.com/talks. And once again, thank you so much for attending, and I hope you learned something new out of this session.
Awesome. Thanks very much, Arsh. That was fantastic. So I guess one question from me, I'm not sure we have any questions in the Slack at the moment, but one question from me would be, obviously there's a bit of a complication with Kubernetes, not with Go, when it comes to dependencies, because you have this distinction between packages and dependencies, packages and modules, sorry. Does the depstat deal at all with at the package level, or is it just at the sort of module level?
It's at the module level, so.
Okay, brilliant.
It basically uses whatever the information is in the go.mod file. And if you're familiar with this command called go mod graph, which generates the output, and that is how it works.
Brilliant. Chris, anything from your side?
No, that was awesome. It was great to get some background, and I think it's always good to encourage folks to get involved in the community. I think we talk about open source, about being a big community, but sometimes it feels like there's quite a step up. I think the go-to for most people is to contribute to this. I need to be able to write low-level Go code, or to be able to contribute 1,000 lines of code. The simplest way to contribute is just to get involved and maybe just do some few typos and go the obvious one is the docs pages, but also even just contributing to the actual source stuff. As Arsh said, coming from a non-Go background and very quickly being mentored and so on, I think it's the one thing I love about this community. And not just we talked fondly about the actual community, the meetup side of the communities earlier, but I think the actual social side of things with the whole community is really strong. It's so welcoming. Anyone from any background can come into there. And again, to echo Arsh's comments, don't let your imposter syndrome get the better of you. Everyone is welcome, and once you get in there, you realize that none of us know what we're doing. So we all started from somewhere with a complete blank slate, and there's a good chance that you've got something to bring to the table that we don't have already, and the community doesn't have already. So
yeah, I think the longer I do this, the more I realize I don't know. But yeah, awesome. Well, we're a little bit ahead of schedule, so we've got a little bit of time. So what we'll do is
might be worthwhile talking about.
I think what Chris was saying, that showing up, what I've learned and seen is that showing up is the most important part. So if you consistently show up, that is what would matter, and you'll get many opportunities to help and contribute.
Yeah, open source can be really can seem really intimidating, but I think one thing I've learned, especially from the Kubernetes community, is that it's surprisingly welcoming to new people who are looking to contribute. It's not always going to be like the fastest experience. There are something like 2,000 or more open PRs on the Kubernetes repository right now. But when someone does eventually get around to looking at what you've contributed, they're always there and willing to help. So. In that case, Chris, you were going to...
Yeah, I don't know if we've got about 5 minutes before the next talk, so I don't know if it's worth just quickly touching on some of our sponsors. I know we had some hiccups this morning, so we lost a little bit of time. So I guess, I'm going to talk about Tramshed because I think they're doing a fantastic job of hosting us. Tramshed Tech is home to startups from the digital, creative, and tech communities. They are based in Cardiff, so very, very happy to have some UK-based companies involved in this. They're also opening sites in Newport and Swansea very soon as well. No matter where you are in your entrepreneurial journey, Tramshed Tech can help support you grow your business by offering great spaces, access to skills and training, help with business growth and raising capital. They've got a 12-week startup academy supported by Google. and it's currently open to applications. You can apply at academy.tramshedtech.co.uk or reach out to them through the usual social channels for more information. So again, massive thank you for Tramshed Tech for helping host and present this. It's been absolutely awesome. They are a great bunch, and they've also got a fantastic location. I think it's where the Cardiff watch party is at the moment, and we'll be running the pub quiz from later. So really, really great bunch of posts, folks.
Yeah. And on that note, I'll take a moment to call out another one of our sponsors, who actually, two of the people on this call right now, Chris and our next speaker, Tom, are members of this organization. So just want to shout out real quick, Sysdig. The Sysdig Secure DevOps platform provides security, sorry, the Australian came out in me there, to confidently run containers, Kubernetes and cloud, secure the build, detect and respond to threats, and continuously validate cloud configurations and compliance. Maximize performance and availability by monitoring and troubleshooting infrastructure and services. Sysdig is a software as a service platform built on an open source stack.
Awesome. It's quite a mouthful, isn't it?
It is.
Great stuff. Thanks for that, Josh. Thanks for the plug there.